Hello and welcome to our short recording on the general motor program theory. So before we talk about the general motor program theory, what we can talk about is where it came from. Well, it came from a class of theories that is known as motor program theories. So originally the thought was that for every type of movement, or every single movement I should say, there was a specific movement pattern stored away in our central nervous system, whether it was in the motor cortex or whether it was somewhere else, the cerebellum, I don't know. They didn't know. The main idea though is that for every single movement there was a motor program that was selected out of memory, and that was what was then played and brought about skilled action. Now we have an issue that arises when we think about motor program theory. First thing is storage. There would be quite literally millions, maybe even billions of different movement patterns that could be achieved. So how would we have enough storage capacity within our central nervous system to be able to store all the different types of movements that are possible? The other issue was that we have novelty. How do we explain that we could do a new skill all of a sudden? Is it that we would just magically produce a new motor program and store it away in our central nervous system? So there was issues with that motor program theory. So Schmidt, what he did was he did a bit more thinking, and he put a general in front of that motor program theory. And so what he stated was, and found experimentally I should say, is that we have these general motor programs that have these invariant features. What do I mean by invariant features? Well, I'm talking about relative time, relative force, and order of events. So these are the inherent features of the movement itself, a unique set of characteristics that defines the general motor program and does not vary from one performance of action to another. So putting that into context, thinking about, for instance, throwing. If we were talking about a motor program theory, every different type of throw, whether we do it completely over arm, maybe a little bit to the side, or a side arm throw, all of those would be different motor programs. But under the general motor program theory, what we have seen is that we have these relative time, force, and order of events. So we can generalize it into a throwing program. Now, what do I mean by relative time, relative force, and order of events? Well, the way that I like to think about it is, imagine writing your name, my name for example, Zac, Z-A-C, has Z that comes first, A that comes second, C that comes third. So if I change the order of those events, then I've changed the general motor program. So maybe I write it backwards, Kaz. That's no longer my name, so I've selected a new general motor program. It also states that the relative time, if I was to write my full name, Zac, in 3 seconds, for instance, and possibly it took me 1 second per letter. So 1 second for Z, 1 second for A, and 1 second for C. That's the relative time. My overall time was 3 seconds, but my relative time was that 1 second was apportioned to each letter. And you can think of it as the overall force can change, but the relative proportion of force given to each letter in my name would stay constant. If I was to change the relative time or force, then I'm using a new general motor program. So we still have an issue of flexibility. We know that if we are walking and then we speed up the walking, we eventually start to jog, for instance, and then we eventually start to sprint or run and then sprint. These are different motor programs, general motor programs that are being used, because relative time, relative force, and the order of events changes between walking to jogging, jogging to running, running to sprinting. So that means that we have shifts in general motor program selection, but if I'm walking at 1 kilometre per hour, 2 kilometres per hour, 3 kilometres per hour, the speed, overall speed has increased, but the relative portions or the invariant features haven't changed. So I'm still utilising the same general motor program. So how do I get that flexibility in the system that allows me to now speed up by 1 kilometre at a time? It's called the schema. So the schema is this abstract representation of rules that govern movement. So up there in the central nervous system, we've got this weird and wonderful organ that allows us to think abstractly. And part of that in this general motor program theory is the ability to abstractly govern the overall force, the overall duration of muscles used. So we're able to then modify, if you like, or adapt our movement patterns. So these parameters, as they're referred to, that are governed by the schema, can introduce adaptation and modification to the general motor program. So the features of the general motor program that can be varied from one performance of a skill to another. The features of the skill that must be added to the invariant features of the general motor program before a person can perform a skill to meet the specific movement demands of the situation. So what that's saying is that we might be performing the gait cycle in a certain environment. Our schema goes, okay, what we need is this overall force, this overall duration, and we need to utilize these muscles to flexibly modify our general motor program to achieve that skilled action. So we might be saying, okay, we're jogging, okay, we're using the jogging general motor program. Then we see something in the environment that requires us to react and start to sprint. So we shift from using the jogging general motor program to then using the sprinting general motor program, but we need to get the context, the modification of movement information from the schema to tell us how fast we might need to be sprinting and how hard, I should say. So that is our general motor program theory in a nutshell. We'll be covering that further in class. Thanks for listening, and talk to you soon.